Hey, what's up, you guys? Welcome to the Incredible Academics channel, right? Where we make pure maths seem like maths lit, right? We're making maths easy. So, look, like I promised, we're going to be looking at one of the most slightly challenging, things in calculus, right? Finding the x-intercepts of a cubic function. This is literally, what some of the learners kind of like struggle with, right? But we're going to look into it, and hopefully by the end of the lesson, you guys will be, wait, I'm just trying to fix this. Right, cool. Yes, hopefully, after the end of the lesson, you guys will be, quite comfortable with finding the x-intercept. So now, when you're given, let me see, we're starting with this one, right? When you're given a function like this, and now you have to find the x-intercepts. So obviously, all right, this is going to be a cubic function, right? Right, this is what your cubic function is going to look like. But the question is, what are these values here? What values are we going to have over there? Because those values are actually very important when it comes to plotting the function. Yes, we have discussed how to find the, the turning points. We are quite comfortable with that. And I am pretty sure, right, I can bet you that you can find the y-intercept, right? Let what be what. You guys know the story. But anyway, now we're going to be focusing on finding the x-intercepts. So, and to find the x-intercepts, you have to let what? Let g of x be 0. In other words, let y be 0. So we're going to do exactly that. So we're going to, okay, x cubed minus 5x squared minus 8x plus 12 is equal to 0. So now we're faced with a problem. We need to then, solve this, right? But we can't use a quadratic formula because can you see that the highest power is 3. So with the quadratic formula, that's when that portion of the function doesn't exist. Then you can use your quadratic formula. But this time around, we cannot, which is a problem. So what do we do? What do we do? So what we need to do is we need to first of all, we need to guess, right? We need to guess. So we're just going to think about any value, right, of x. It could be x equals to 1. It could be x is equals to minus 1. It could be x is equals to 2. X is equals to minus 2. It could be x equals to 3. X equals to minus 3. It could be any value that makes the function g to be 0. Do you understand? But we don't know for sure which value is going to be. So we're going to say, okay, let's test g of 1. Right, and see what we're getting. Let's also test g of minus 1. Whatever value that gives us a 0, then we know we've got a root. So we basically trying to predict a root, right? The first root, we're just going to predict it. So, okay, you can see that, let me write the g of x. This is basically our g of x. So g of x is equal to that. So g of 1 means that in place of g, we're substituting what? 1. So let's substitute the 1 and see what we're getting. So I'm going to say 1 cubed. Remember, we are looking for any value of x that's going to give us 0 when we substitute it. We are basically doing trial and error. We are looking for a root. So you can see that g of 1 gives us 0. In other words, when you substitute 1 in place of x by the function g, right, we're getting a 0. So we are no longer going to do trial and error. We've got the x value which gives us 0, right? Which gives us 0. That is x equals to 1. And you can try it out, substitute your your x equals to 1 by a function and see if you're not getting 0 as well, right? I'm getting 0 on my side. So cool. Now that we know that, okay, x equals to 1 gives us 0, we can sort of like reverse this whole equation. X equals to 1 is our root, but remember, before you get x equals to 1, you probably said x minus 1 is equal to 0. So we just take the 1 to the other side, right? So we know that this is going to be one of the expression when we factorize g of x. In other words, so x minus 1, we're going to have something like this, right? X minus b, x minus c, you know, and this is going to be our g of x. That's what it means when we say x minus 1, right? X minus 1 is a factor, right? Is a factor. So in other words, if we had x is equal to negative 1, then we'd say, okay, x plus 1 is going to become a factor. Do you understand? So we are just basically taking the 1 to the other side, then we give it a name that it's what? It's a factor. But now that we're here, we're about to finish up with the problem, right? Now that we've identified the first root which makes our function to be 0, okay? So what do we do, you know, once we've gotten to this point? So we're going to say, okay, we know that x minus 1 is a factor. All right, now we're going to ask ourselves, okay, to get x cubed, right? That x cubed over there, what do we need to multiply x with? Right? X squared, right? And then also to get the last term, which is positive 12, right? What do we need to multiply negative 1 with? I bet you said negative 12. Okay? And then the middle term, we're just going to say it's kx. It's kx. All right, so the middle term is just kx, and we're going to do that with all the problems that we're going to be dealing with. So now we're trying to figure out what the middle term is going to be. So we're going to use a formula called, okay, k is equal to apples and bananas. All right, k is equal to apples and bananas. That's the method that we're going to be using. But remember, our g of x is of the form ax cubed plus bx squared plus cx plus d. So, and if you check, right, our a, the coefficient of x cubed, that's 1. Our b, the coefficient of x squared, that's negative 5. Our c, the coefficient of x, that's negative 8. Our d, that's just 12. Okay, so a is basically equal to 1, and b is negative 5. Cool. Now what is p? P, it's the root. Okay, p is the root that we found using trial and error. So p is equal to 1. Okay, so now let's go back to that formula there. All right, so now let's substitute. A is 1, the p is 1 as well, and the b, it's negative 5. Right, the b is negative 5. So meaning that 1 minus 5, that's negative 4, right? That's negative 4, meaning that our k is negative 4. So let's go back to that expression over there and substitute negative 4 in place of k. So meaning that we've got what? X minus 1, x squared minus 4x, remember k is negative 4, minus 12. Okay, so at this point, what you can do is you can then further factorize this, right? So it's going to be x minus 1. We're just going to further factorize that. X minus 1, x, right? And then the factors of 12, that when added, they give us negative 4, and when multiplied, they give us negative 12. That's probably 6 and 2, right? But the sum of 6 and 2, in order for us to get negative 4, we need to have minus there and plus there. Then minus 6 plus 2, that's negative 4. But minus 6 times 2, that's negative 12. Do you understand? So this is our g of x, right? And obviously now, to find your what? To find your roots, you just going to say, okay, x minus 1 equals to 0, x plus 2 is equals to 0, x minus 6 is equals to 0. Therefore, x equals to 1, or x is equals to negative 2, or x is equals to 6. So we've got all the x-intercepts. So meaning that, okay, we know that here we're going to have minus 2. Here we're going to have 1, and here we're going to have 6. So we've got the x-intercepts now. Okay. All right. Looks complicated, but yeah. And then let's quickly look at the second problem. Q of x is equal to that. Now you can see that the x squared term is missing. So what we're going to do is that we're going to say, okay, this is the same as minus x cubed plus 0x squared plus 3x, right, plus 2. You can see that, okay, now it looks like the cubic function that we used to, because the x squared term seems to be there, just that the coefficient is 0. Okay, so now how do we simplify this problem? We do exactly what we did on the previous problem, right? Exactly what we did. So we're just going to first of all start off by guessing the first root, right? We're trying to figure out what's the root that's going to give us a 0. So we're just going to say, okay, minus, let's plug in 1 cubed and plus 3 into 1, right, plus 2. We're getting a 4. So meaning that this is not the one, because the actual root needs to give us a 0. So let's try minus 1, and there we go. Minus 1 gives us a 0. So meaning that q of negative 1 gives us 0, right? If you substitute, negative 1, right? So when x equals to negative 1 is a root, right? But if you take the negative 1 to the other side, then x plus 1 is a factor. Okay, so meaning that, and remember, the root is our p. Okay, and you can see from here that the a is equal to negative 1, the b is equal to 0, the c is 3, the d is 2. Although we don't really care much about the c and the d, we're just interested in the a and the b because we're using the apples and bananas method. Okay, so x plus 1 is a factor, so meaning that we can immediately rewrite the q of x. Q of x is equal to x plus 1, right? And then we're going to have that other bracket over there. So what do we need to multiply x with to get minus x cubed, right? Minus x squared. And the last term, what do we need to multiply 1 with to get plus 2? That's just 2, all right? So now in the middle term, that's going to be kx, right? We're getting somewhere. So we need to find the middle term now. We know that the middle term is given by apples and bananas, right? And we already know what the a is, what the p is, what the b is. So remember, our a is 1 from there, the coefficient of x cubed. Not positive 1, but negative 1. Sorry about that. So that's negative 1 times what? The p, which is negative 1 as well. Remember, negative 1 plus the b, but the b is 0. Okay, so our answer is just going to be positive 1, meaning that, okay, now we can substitute our k in place of by that expression over there. So q of x is equal to x plus 1 and then minus x squared plus what? Plus x plus 2, right? So now what we can do is we can say, okay, let's factorize the negative 1 over there so that it's easier for us to factorize. So x plus 1 minus x squared minus x minus 2. So this way it looks pretty, isn't it? So you can take the minus 1 this side, becomes minus x plus 1 x squared minus x minus 2. Okay, so minus into x plus 1. So now we just try to factorize this, right? So xx, so the factors of 2, 2 and 1, negative, positive, and we're done. So we've got the expression for q of x in terms of its factors. So we know to find the roots, we need to say q of x equals to 0. But we know that q of x is basically minus x plus 1, right? X plus 1 and x plus 1 again, x minus 2. Okay, so this we set equal to 0. So this is going to fall off. So basically x plus 1 equals to 0, or x plus 1 is equals to 0, or x minus 2 is 0. So x equals to negative 1, or x equals to 2, right? So if you're getting the same roots like this, that means your function is basically kissing the x-axis by that root. So we're going to have something like this. But you've already seen that the coefficient of x cubed is negative, so we already know what type of function to expect. So we're going to have something like this, something like that, right? Something like that. But the problem is that now the function is kissing the x-axis. Why? Because we've got the same root here. X plus 1 equals to 0, x plus 1 equals to 0. So meaning that it's going to be like this. Can you see that it's kissing the x-axis there? It's kissing the x-axis there. In other words, it's got the same root. It's two roots, but they're identical. So, and then, yeah, and this is also a turning point, right? So, yeah, we've got one of those special functions. And then here, here we're going to have what? Here it's going to be 2. Okay, so that's that, right? And then let's look at the last one. I see, now I'm getting tired. But let's look at the last one. I'm pretty sure it's not going to take that long. We're going to repeat the very same process, right? We're going to start off by looking, plugging in different x values. We normally start at 1, and then you go to minus 1, and then 2, minus 2, 3, minus 3, so on and so forth, until we actually find an x value which gives us a 0. Okay, so let's start with 1. So 1 cubed minus 6, 1 squared minus 14, 1, right, minus 4. It gives us negative 32, meaning that it's not the root because there's a remainder there. Let's try negative 1. Negative 1. Negative 1. It gives us a 2, so it's not going to work. Let's substitute 2. Then we'll substitute negative 2 if we don't get a 0. 2. Negative 40, not working. So negative 2 now. Negative 2. Negative 2. Not working as well. Let's go to 3. Alright, so this is what you need to do. Keep on guessing and guessing. Oh my goodness. Okay. 3. Negative 46, not working. Negative 3. Negative 3. Negative 3. Not working. Let's go for let's go for 4. Right? We just gotta keep on trying, and we gotta be as fast as possible because time is running out. 4 minus 28, negative, negative, negative. Right. And then let's try minus 5. We just gotta keep on trying, eh? Minus 5. Hopefully we'll find a root eventually. minus 5 also not working, right? You gotta be patient. Be patient, be patient. 26. Let's go for 6. Hopefully this is the last one. Alright, 6, 6, 6. 6. No, not working. Negative 6, negative 6. Alright. Okay, seems like this function doesn't have any roots. Yes, it doesn't have any roots. So, like, normally with the functions that you guys are going to get, definitely, because they carefully select them, so you guys are definitely going to find some roots. But that's basically what you do when you're on the search for the roots, right? So, yeah. You just gotta keep on trying. So the root is basically at let's see, 6. So d of x is supposed to be 2x cubed minus x squared minus 25 minus 12. So I made a mistake. So d of x is supposed to be 2x cubed minus x squared minus 25 and then minus 12. So I used this one first and then I realized that it doesn't have any roots, so I then came up with my own. But unfortunately, when I was actually writing it down, I copied the wrong one. But anyway, let's carry on. Let's see if this one is going to work. 1 cubed minus 2 squared, not 2 but 1, just doing the trial and error thing, minus 25. So I also did the same thing when I was selecting these problems. I selected specifically the ones that I knew that they've got roots. That's what they do, when they're setting your papers. They're not going to give you something that doesn't have any roots, right? So yes, and the roots, I mean, they normally lie between minus 3 and 3, nothing complicated. So yeah, let's see okay, 3 and 4, I'm pretty sure we're going to find something here. 3 and 4, I'm sure. So there we go. We can see x is equals to minus 3 is a root. In other words, it gives us a 0, and because d of minus 3 is 0, and therefore we take the minus 3 to the other side, x plus 3 is a factor. Okay, so now look, this is a factor, but remember this is also our p, okay? And you can see that by the dx equation, a is equals to 2, b is equals to negative 1, c is equals to negative 25, and d is equals to negative 12, right? So now we know that, okay, d of x is equal to what? D of x is equals to the factor, right? And then now we need to figure out what's going to be the quadratic expression here. But okay, we're going to, first of all, we need to ask ourselves, what do we need to multiply x plus x with to get 2x cubed? 2x squared, isn't it? And then what do we have to multiply negative 12 with, 3 with to get negative 12? That's negative 4, isn't it? And then the model term is just going to be kx. Okay, so cool. Now we need to figure out what the k is. Remember, k is equals to apples and bananas. All right. Now look, apples and bananas. We know that the a is what? The a is 2. The p is negative 3, our root. the b is -1. So this gives us what? -6, -1, which is -7. So cool. D of x is now equal to what? X plus 3, right? X plus 3, and then 2x squared minus 7x minus 4. All right, so we now need to factorize that expression over there. Okay, so 2 times 4, that is 8. So factors of 8, that gives us -7. That's 8 and 1. So we know we're just factorizing this. So 2x squared minus 7x minus 4, that's equal to 8x minus 8x plus what? 2x squared minus 8x plus x minus 4. So we just do our grouping thing. So yes, so 2x squared minus 8x plus x minus 4. So we take out the common factor there, 2x out, x minus 4 plus x minus 4. So x minus 4 and then 2x plus 1. All right, so now we've got the factorized version of that expression. So d of x is basically x plus 3 and then 2x plus 1 and then what? X minus 4. All right, so we know, all right, we all know that to find the roots, d of x must be equal to what? 0. Okay, so meaning that x plus 3, 2x plus 1, x minus 4 must be 0. So x plus 3 is equal to 0, or 2x plus 1 must be 0, or x minus 4 must be 0. Therefore x is equal to minus 3, or x is equal to minus 1 over 2, or x is equal to what? 4. And the problem is pretty much done. And obviously you can see that the coefficient of x cubed is what? Positive. So our function is going to be like this. All right, and then here it's going to be your first root, the second root, and your third root. That's it. And I hope you guys learned a lot. Don't forget to like, subscribe, and share, and shout out.